In 12-6, we are going to move on to what we call permutations and combinations. Now what I'm going to do is at the very beginning, before we even start the lesson, I want to talk to you about the major difference. Permutations is the number of ways something can happen, if order is important. Okay? Now, a combination is very similar. A combination is the number of ways something can happen, but the order is not important. It's just you're looking at groups instead. So we can write order, not important. Now you might say, what in the world? How are those even different one from another? Let me describe it to you like this. When I got married, whenever we did our reception, I had to decide on who was going to sit at what table for the reception. I was concerned about the combinations of people. If I were concerned about the actual particular seat they would be in, I would have been concerned with the permutation of the people. I didn't care where people sat on the table. All that I cared is that they sat at their group. I was concerned about the combination. I was concerned about the group of people. I was not concerned about the order in which they sat, which would have been the permutation. If you play sports, your coach is pretty, particular about the permutation of how they line you up. Maybe in volleyball, or maybe in, if order is important in basketball, the order in which you play the particular spot, that would be a permutation. The team itself would be a combination. Now looking at the beginning problem, which sometimes we skip, that would be a great one for you to try and come back together and do together. And you're saying you're at this amusement park, you want to go on all the rides, how many different ways can you go about this? So that one, whether you know it or not, you're actually going to do a permutation. One more thing I do want to talk to you about that's not listed is called the fundamental counting principle. Now what the fundamental counting principle does, it is a quick way to count how many times, it's a quick way to count, like how many times something can be put together. Now let's go down and I'm going to teach you about the fundamental counting principle. Now this will be very helpful in Algebra 2. This is actually where I begin in Algebra 2. We start kind of in a fun way in permutation and combination. So get it down this year. You're going to be really happy you get it down this year for next year. Key concept, the multiplication counting principle, also known as the fundamental counting principle. If there are m ways to make a first selection and there are n ways to make a second selection, there are m times n ways to make the two together. For example, the example is very helpful. 5 shirts, 8 pairs of shorts. How many do you have total? 5 times 8 is 40. What do you think students might do sometimes as a mistake if you have this question on a test? A lot of times people will do 5 plus 8 is 13. And they'll say, oh, you have 13 things that you can wear. No, you don't have 13 outfits. For every single shirt, you have 8 choices. So you do 5 times 8. Okay, next little item here is what we call, it is a short way to write products. And remember, products means multiplication. And we're going to get to that in problem 2. You're going to see an exclamation point. Now this is I thought this was really amusing because my brother actually called me and he said, Amy, I'm at work and I see this number with an exclamation point. What in the world does this mean? So I told him that's a word in math called factorial. Maybe I'll have to call him back and ask him what he had it for. I can't remember. But for whatever reason, and my brother needed to know what factorial was, his job or something. But what factorial does is it multiplies all the way down. So let me show you just an example. I don't really like this paragraph. Here you go. It tells you that if you have 5 factorial, and that's what the exclamation point means. It means factorial. That is a short way of writing 5 times 4 times 3 times 2 times 1. That's what 5 factorial means. So let's see, that's 20 times 3 is 60 times 2 is 120. So factorial is really going to be one of the key concepts for this lesson. All right, now let's move on to what we call a permutation. Now I already described permutation a little bit. It's about a seating arrangement. A permutation is exactly that. It's an arrangement of objects. And you want the specific order. Now if you look, they give you a pretty boring example down here. This is the way that you can arrange the letters A, B, and C. So you can do A, B, C, A, C, B, blah, blah, blah. You know, you can do something more fun than that. But you should notice that there are 1, 2, 3, 4, 5, 6 ways that you could arrange the letters A, B, and C. Now whether you know it or not, that actually uses the fundamental counting principle. Let's look at the notation of permutation. The expression P n of r represents the number of permutations of n objects arranged r at a time. So take a look at this really funny looking formula. Kind of goofy, isn't it? This P means permutation. This n is how many in the group you want to select. This r is how many, the n is how many are in the group. The r is how many you want to take. So let's think of a real life example of this example here, because you can see numbers, you can see the way it works out. But what could be an example of when we have n objects and you want 2 of them? Maybe, for example, this could represent a class of 8 students, and the teacher needs to select 2 of them. Now, how many ways do you think, with trying not to look at the answer, how many ways do you think the teacher could select two people out of 8? Can you believe that the actual answer is 50 particular people? Now, this is if not only do they want to select 2 of them, they want to select 2 of them in some type of order, in order to stand. Maybe they're taking a picture of 2 students. What are the different ways that you can arrange 2 of your students in one picture? There are 56 different ways, if you can believe that, if you have a group of 8. Now, this long, drawn-out process, I'm going to walk you through it. If you want to take a look at it, go ahead. But I'm going to walk you through it in another example. Same thing happens with combinations. Okay, and the combination is when you don't care about the order. If you're just selecting 2 side dishes, you don't care the order that the waiter or the waitress brings them out in. You're just selecting 2 side dishes out of 5. That would be a combination. So if we take a look at this problem, this time they did a combination 2 of 8. So this time maybe your teacher has a class of 8, but this time she just wants a group of 2 students. She doesn't want to put these students in order. She just wants to select a particular group of 2 students with no order. Now, can you believe that there are 28 ways of doing that? Again, that long drawn-out process, that's something that I'm going to teach you as we begin to move on. All right, problem 1. Now, this time it says to use the multiplication counting principle. I would like you, as we move on through this, to try not to, it sounds funny, but try not to read these directions at the top. I want to know if you understand when to use what. Use the diagram below. How many ways are there to get from the first floor to the 3rd floor using only escalators? Why don't you pause the video and try to decide this for yourself? All right. Well, hopefully you considered that the fact that you have to get from the 1st floor to the 2nd floor, right? So to get from the 1st floor, from floor 1 to floor 2, there are 2 options to do that, and that's to get from floors 1 to floor 2. There are 2 options. Now, in order to get from floor 2 to floor 3, you should notice that there are 1, 2, 3 options. So how many different ways are there to go up to the 3rd floor using escalators only? 2 times 3 makes 6. If you need to write them all out, then do so. Moving on. A pizza shop offers 8 vegetable toppings and 6 meat toppings. How many different pizzas can you order with 1 meat and 1 vegetable? So you have 2 decisions you need to make. You need to make the decision for the meat. You need to make the decision for the vegetable. Now for the meat, you have 6, and for the vegetable, you have 8. Multiply them together, you have 48 choices in all. Okay, let's try this again on the got it. Now these can become increasingly difficult. We'll talk about more difficult problems when you're in Algebra 2. Problem 2. Now this time it does say permutations, but let's make sure that we understand why it's a permutation. Baseball. How many different batting orders can you have with 9 players? So what we need to realize is that the order is very important. If you had Mr. Phillips for your coach, he had to decide the batting lineup. He had to be very particular with who should go first, who should go second, so on and so forth. So if we have 9 players, we need to have all 9 of them, batting. So we're going to use a capital P to stand for the permutation. We have 9 people to pick from, and we have 9 people that we're going to pick. It says we're going to do all of the players. It doesn't say you're only going to pick 3 players. So to do this formula, here's how you do this. Now we can write the formula up top so you don't have to keep flipping back and forth. You have P of n and r. Now that equals, you put n factorial on the top, you put n minus r factorial on the bottom. So put that on there, and then we're going to apply our formula. So you have the formula up here. I'm going to scroll up so we have it at the top of the screen. How many players do we have? 9. So we do 9 factorial. Over, how many players do we have? 9. How many do we want to pick? Minus 9 factorial. Now let's make a special note at the top here. A rule that 0 factorial equals 1. That's like asking how many ways can you order 0? You can order 0 things one way. Alright, now the top is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Over, well you have to subtract first. 9 minus 9, 0 factorial. So it's over a big whopping 1. So really all we have to do is 9 times 8 times 7 times, and this, so if you want to write a little equals 1 down here, you can. That equals, if you can believe it, 362,880 different ways that the coach can line them up. A very, very large number, considering we only had 9 people to do this with, isn't it? Okay, swimming pool has 8 laps. Yeah, 8 lanes. In how many different ways can 8 swimmers be assigned lanes for a race? You see that word assigned? That means that order is very, very important to this problem. Now, we have a permutation because of order. We have 8 total swimmers, and they want us to have all 8 swimming. So on the top, we do 8 factorial over 8 minus 8 factorial, since we want all of the swimmers to be in the lanes. Well, the bottom is 0 factorial, or a big whopping 1. The top is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you have to multiply all of those numbers together in the top, and to arrange 8 people in a specific order, if you multiply them all together, if you can believe it, again, these are very large numbers, 40,320 different ways to assign lanes. Crazy how many choices there are. Now in problem 3, the reason problem 3 is going to be different than problem 2 is because in problem 3, we are not going to use all people. Not going to use all the items. Okay? So let's go straight to the music question. A band has 7 new songs. They want to put 5 of them on a demo. How many arrangements of the 5 songs are possible? So we have the word arrangements. We can see that order in this problem is very important. Because order is important, we used permutation. The group has 7 total songs, but they only want to pick 5 of them for the demo CD. So on the top of this, we put all 7 songs, and on the bottom, we do parentheses 7 minus 5 factorial. So you can see how the bottom is different now. So the top is 7 times 6 times 5 times 4 times 3 times 2 times 1. And the bottom, well, 7 minus 5 is 2 factorial, is 2 times 1. Now you have a couple of options here, everybody. You can multiply the top together and multiply the bottom together and divide. Or you can remember the rule that if you have multiplication of 2 on 1 on the top and multiplication of 2 on 1 on the bottom, they cancel. I don't care if you multiply the top and then divide by 2 on the bottom, or if you just divide at the beginning. It's much easier to cancel if you can. So I end up with 2,520 different types of arrangements. So I'm going to put ways to arrange songs. Crazy, isn't it? They're only going to use 5 of their 7, but they still have over 2,500 ways to do that.